Okay, so now we're in Chapter 5, and we're going to be looking at continuous probability distributions. Like in Chapter 4, we looked at a general discrete probability distribution, and then we looked at a specific example known as the binomial probability distribution. In Chapter 5, we're looking at a specific example of a continuous probability distribution known as the normal probability distribution. So recall, a continuous random variable has an infinite number of possible values. Those are measurements, and they can take on any value, in this case between 0 and 24, because we're looking for the time spent in a day. All right, so the normal distribution is a particular continuous probability distribution. It is considered by most to be the most important continuous probability distribution in statistics. And it is, the graph of it is known as the normal curve, sometimes also known as a bell curve. In the properties of the normal distribution, the mean, the median, and the mode are all equal to each other. It is symmetric, and it is symmetric about the mean. The total area under this curve, the amount of blue shaded in, the total area is equal to 1. And as the normal curve goes away from the mean to the left or to the right, the curve approaches the x-axis but never actually touches it. Now, there's a property of the normal distribution known as the inflection points. The inflection points are located when the curve goes from cup down. Do you see how up here it looks like it's a cupping down to cupping up? Now, that point, the exact value of that point is just an estimate, because we all might put that point someplace else, but that point is located on either side of the mean, 1 standard deviation from the mean. So it does give us a way of estimating the standard deviation when we're given this bell curve. Now, this normal distribution can have any mean and any positive standard deviation. For example, if you go from the highest point, drop down, we see the mean is 3.5. This inflection point falls here about 2, so about 1.5 units from the mean, which means the standard an approximation for the standard deviation is 1.5. Same here, drop down from the highest point, and we get a mean of 3.5. Find the inflection point, drop it down, and we see that there is about 0.7 units difference between where we drop this down and here, and the same for that example there. The mean always gives the location of the line of symmetry. The mean is always where you fold the bell and you would get it symmetric on either side. And standard deviation describes the spread, how spread out the bell is. So which of these curves has a greater mean? Well, the mean is located here at 15. Over here, the mean is located at 12, so A has the higher mean. Which one has the greater standard deviation? Well, we're looking for the bell that is the widest. The B curve is wider, so B has the greater standard deviation. For example, let's try to estimate the standard deviation. We drop this down and we see the mean is about at 675. Find where we think the inflection point is, drop a curve down, measure the distance between here, and it's approximately 35. So we say the standard deviation for this distribution is about 35. Now we're going to look at a special type of normal distribution known as the standard normal distribution. The standard normal distribution has a mean of 0. If you drop down from the highest point, you drop at 0, and a standard deviation of 1. And we can standardize any x value using the formula we saw in section 2.5, finding the z-score, which is value minus mean divided by standard deviation. So if we have we can now take any random variable x and transform it into a z-score, and then we can use the standard normal distribution to find area under the curve, which we'll see later is equivalent to finding the probability. So we start with the normal distribution, we standardize the score, and then we'll be in the standard normal distribution. And we have a table in your book known as the standard normal table, which we will be using to find these cumulative areas which are equivalent to probabilities. For example, let's find the cumulative area. Oh, well, before that, let's look at some properties of the standard normal. Now, the cumulative area, which means area shaded to the left of negative 3.49, well, approximately nothing is shaded to the left, so that area is close to 0. The cumulative area increases as the z-score increases, and if we're looking exactly at the halfway mark at the 0, at z equals 0, we've shaded in exactly half of the bell curve, so that area is 0.5. And if we go all the way here to positive 3.49, we have shaded almost all of it to the left. Remember, cumulative area is area shaded to the left. And so that cumulative area for z equal to 3.49 is very close to 1. This is a standard normal table that you'll find in your book, and you can print it out if you like. Now, if we want to find the cumulative area that corresponds to a z-score of 1.15, well, we find these first two values, 1.1 along this column, and then the 5 is in the 100th place. So we look along the top and find the column with the 5 in the 100th place. See where those two intersect at 0.8749. So the cumulative area, or the area to the left of 1.15 on the standard normal curve, is 0.8749. If we want to find the cumulative area that corresponds to a z-score of negative 0.24, again, we look at the first two here, negative 0.2, which is here. Then we look for the 0.04 in the 100th place, and we see that that area, or area shaded to the left, is approximately 0.4052. Now remember, with the standard normal curve, 0 smack in the middle. So if we have a negative value, we expect to see the area shaded to the left to be less than 0.5, and here we got about 40% of 0.4052. So let's look at how we go about doing this. One of the very first things you should do is sketch the normal curve and shade the area that you're looking for. If we're looking for the area to the left, that corresponds exactly to the value found in the standard normal curve and the standard normal table. If we were looking for, use the table to find the area for the z-score of 1.23, we see that that corresponds to, in the table, 0.8907, and that is the area shaded to the left of z equal to 1.23. This corresponds to finding the probability that z is less than 1.23. If we're looking to find area to the right, let's say 1.23, well, when we looked in the table, we saw that this value here was 0.8907, but this area here in pink and this area here in blue together add to 1. We're trying to find the area in blue, so this area here is 1 minus 0.8907, which is approximately 0.1093. And if we're trying to find the area between two z-scores, we look up the area 1.23. That, remember, was 0.8907. But that includes all of this blue area and this pink area over here also. We want to subtract this piece out, so we look up negative 0.75 and find that area to be 0.2266. The area in blue is all of this area, 0.8907, minus the 0.2266, and we get the area in blue is 0.6641. Let's do a couple more examples of that before you get started trying some on your own. Find the area under the normal curve to the left of negative 0.99. So you look on the table and you look up negative 0.9, then you look along the top and find 0.09, and you would get 0.1611. Let's find the area shaded to the right of 1.06. So when we shade it, area to the right is there. We look up 1.0 in the first column, then we look for 0.06 along the top, and we find that that area here, the area here in the white, is 0.8554. What we're looking for is this area in the blue. So this area in the blue is 1 minus 0.8554, or 0.1446. Let's find area between two values. We're looking for the area between here and here. We look up 1.25 in the table, and we see that that area is 0.8944, but that includes all the way over forever this way. We want to subtract out this piece here, so we look up negative 1.4050 and see it's 0.0668. 0.8944 minus 0.0668 is the area shaded in blue, or approximately 0.8276. All right, that's the end of section 5.1. Now it's time to go to the Course Compass website and practice with some homework problems.